with Reaktor for about 3 years now. The past year I've been working here for the New York office, and I've been using React pretty much since it came out, so for about 2 years now, and been using Node for about 4 years, so quite familiar with both of those technologies.
Yeah. So what we're talking about today to you is what we've been finding that is something that's really cool and kind of a new way of doing things. So we're going to talk about not isomorphic React. I don't know if you've heard, but that term is outdated. It's universal now. None of you heard that joke. Okay. Tough crowd, guys. Come on. Anyway, so we've been going to talk about universal apps with React, which is something that we've been doing and working around with lately. I'm going to quickly tell you guys about Reaktor and what we do, and then we're going to move on to the exciting stuff. So yeah, we are a creative technology company. Basically means that we design and implement kind of bleeding edge services. We don't do rather small projects, but try to focus on really kind of interesting and difficult projects for our clients. We've been around since 2000. We have offices in Helsinki, which is our headquarters. Then we have offices in Tokyo, and for the last year in New York. We don't have a specific domain. We don't work with, like just this or that or certain type of clients. Some of our clients here in the US are like HBO, NASDAQ, you might be familiar. Some companies, like global companies like Supercells, who make Clash of Clans, Samsung, Finnair, which is an airline. So really different types of companies. So we really actually focus on working from start to finish, which means we don't just do the tech. We have design people, UX people, even like data scientists so we can actually work the whole project for the clients start to finish. Other cool stuff we've done, last year we did the Coding World Championship, which was called Hello World Open. There was teams from 90 countries, I think 4,000 teams or developers. Yeah, 4,000 developers, which was pretty cool. We organized a conference, which is a design and development conference, and then we do like stuff like Kids Coding School. And a lot of people actually work on open source projects at our work, and that's one of the reasons we're kind of here is we've been looking into these things first from an open source perspective, and then kind of integrated those to our work. And I don't know if you used Bluebird, the Promise library. So that's that guy who made that Betka, he works for Reaktor. Bacon.js, the creator of that, works for us. And HTML to Canvas, I don't know if you know that. Actually, Nicholas wrote that. So, yeah, enough small talk, and let's move on, right? So, quick browse of the agenda. First, we'll talk a little bit about React and kind of things we found out, what works with React, why we use it, how we keep the code base clean, and stuff like that. And then we're going to talk about universal apps. I'm going to emphasize the universal part. You're going to get this joke maybe if you find the blog post that talked about it. And yeah, we're going to talk about some of the gotchas we've been handling and some of the issues that come up when you do universal apps with React. So okay, let's just, so we can align this, can we get a quick show of hands who knows React in a way they've used it? Okay, so that's a good amount. Who knows what universal, or if you use the old term, isomorphic means? Okay, so most of you, cool. How many of you have done isomorphic stuff? All right, cool. Okay, so we're not going to cover a lot of like React basics. So if you don't know the basics, hope you can keep up and maybe Google stuff while we're talking. But yeah, we're going to talk about a bit about where we think React and kind of universal apps are going. All right. So the problems that we think React solves, this is basically, it's kind of a simple question for some people. It's difficult for other people. It's when you do a lot of updating in the UI, right? React is a UI library. It solves the problem of mutating or updating the UI. If you've done a lot of JavaScript in the front end, you've probably done some jQuery, and you've kept the state somewhere, and then you change it, and then you have to handle that, and you get really clunky code really easy. And kind of React helps you solve that problem. React helps you kind of update the UI in a nice, really clean way, and how to track, or basically you don't have to track the state that much. Yeah, and it kind of, it expresses the UI in a very nice, clean way. It's a component-based library, so kind of the components are the essence of React. So you create components, and obviously we're going to talk about how you share those components on the client as well as on the server side. Yeah. So, components. Components in React, you might have heard the term low coupling, high cohesion. So basically what this means is that your component have basically no outside dependencies, and they kind of hold inside all the stuff they need to have to render themselves, or you pass them as a parameter, but they don't have outside dependencies. That kind of, it makes your code very clean if you follow this principle. And React makes this kind of easy. You can actually, in React, you can keep the components to contain all the logic, and I don't mean the business logic. You shouldn't put your business logic there, but you contains the logic of how to update your UI. What we've found is that it's nice to actually hold the styles inside. So what we mean by this, you can actually inline styles. You'll keep the markup in the component as well. So we actually mean the HTML. For some people, this might sound weird because you separate a lot of school people tell you have to separate this stuff, but we find that it's actually a good pattern to include a lot of the stuff, like everything inside the component. And this makes kind of an interesting thing that you can actually minimize. You don't have those massive CSS files. You can inline the styles inside the component, and it's valid right there. It minimizes the amount of data you need to transfer.
Yeah, I guess we could go through a simple code example where we could illustrate like how you can combine the markup and the styles and.
Yeah. So let's hope if we go away from this that we'll be able to set it back up again.
Can you see the code now?
I'm bringing it to the.
We probably need to see it here as well.
Yeah, that's going to be a tricky problem.
Just open another editor if you can.
No, I can't do it. Pardon? Yeah. That's the actual correct file.
Yeah. Well, I'll try and walk you through. I can't actually see the code myself now, but I kind of remember.
Because we can't see this.
What it contains. But so basically, we defined all the styles in that single module for that component. We defined the markup, what that component composes of. And as you can see, that we are using this stateless React component here. So the component itself doesn't even have any state. So it takes all the data it needs as a single argument into the function, and it returns the markup that component generates. And through this, we can contain everything related to that single component in that single module, and it makes it very easy to understand all the logic related to that component. And if you need to modify something, it's very easy to see all the styles that are related to it, or if you need to add something or remove something, it's all right there, and it in other words, has a very high cohesion in the code there.
Yeah, and kind of, if you're not that familiar with React, so basically the code for the component is here on the bottom, and you can actually see. Yeah, that's right. Just checking. And you can see actually the parameters that are passed inside. Like this one has heading and the title and stuff like that. So basically, it can render itself. Let's go back. All right. So how to keep your code base clean? This might seem fairly obvious, but kind of you have to divide your components logically. And it's sometimes it's trickier, sometimes it's easier, but a good example that I like to use with React is a play button on a video player is not a good component. If you have a play button, like, don't make a play button component, because you'll have the image kind of hard-coded and you can use it only for that one thing. A button, on the other hand, that's a good component. A button that takes a parameter, like the image of the button or the functionality of the button as a parameter, that's good, because then you can actually reuse that button. You can create a play button as well as a full screen button, as well as, I don't know, sharing button by just, changing the parameters. And this kind of keeps your React code very clean and nice and logical. What you can obviously do is you can combine these components. You can have several layers, so a single component can consist of other components. And this is basically in the heart of React, how it kind of works and helps you to create clean code. Obviously, don't put business logic into your React components. React is a UI library. You shouldn't have it there. You shouldn't have inside hard-coded on how the play button or something might work. So yeah, keep it on the UI layer. Event handling. This is something also kind of non-React specific. You should keep your event handling logic out of React. What we've found is that obviously you need to handle events like clicking on stuff and on the UI. But we found that stream-based libraries usually work really good on the UI side, since most events are actually streams. I don't know if you're familiar with RxJS or Bacon.js, but we tend to use those to handle that logic. Yeah, so what does this kind of mean? What does kind of React then do for you? Well, we like it because it's a shift more towards pure function. I don't know how many of you know what functional programming or the functional programming paradigm? Just show of hands, quick. Yeah, so basically everybody. But you know what it means. I mean, it's a nice, clean way. It's much easier. It's better to organize if your code is in a way, pure function. It's the same thing with React components. You pass parameters to the components, and they will work always the same way and output the same result, as well as in functional programming. And actually in React 0.14, which is a release candidate, it's not, there is actually a component that doesn't have state. Obviously you must have state in some situations, but that's actually pretty cool that you can actually create React components that don't carry state.
And actually most of the examples we're going to go through today are those stateless components. So all the data that they get in are passed as arguments to the function, and they don't actually have any internal state in them. But so why do we create universal applications? To me, I think the biggest factor is the performance. So I don't know how many of you have heard this statement a lot of like front-end developers use, where they state that we don't have any non-JavaScript users. And that's never the case. All your users are always non-JavaScript users until they have actually downloaded your JavaScript. If your application is dependent on like downloading the JavaScript and then doing some AJAX requests and then doing the first render, it's going to take a lot longer to do the first render for the user than it would if you would just serve the minimal HTML and styles to the user when they request the page for the first time. And this kind of leads us to progressive enhancement. So I don't know how many of you are familiar with the term progressive enhancement. All right, so it basically means that you should have some sort of like a baseline for all your users. And in terms of a web application, that baseline could, for example, be that you have like HTML and styles that you serve to a user. If a user is able to download your markup and your styles, they can at least see the content on the page. They might not be able to interact with all of it that's displayed on there, but at least they can see it and start browsing. But with progressive enhancement, we then try and add some more features on top of that, add like layers of functionality on top of that baseline. So for example, for a single page application, that could mean that we load the JavaScript, which turns the application into a single page application, or another progressive enhancement could be that we add some sort of like caching or offline support or whatever. So just add layers of functionality on top of the baseline, which enriches the user experience. And for a universal application, it's very easy to set up your application so that you serve them just the HTML styles, which allows the user to get that first render very fast. They're not dependent on getting the JS payload. That you can easily set your website to load the JavaScript asynchronously, and it'll get there when it gets there. They can still browse the website and use it, and in most cases, the JavaScript will probably kick in by the time the user actually performs some action, but just to get that first render as soon as possible is very important. And we could actually look at some more code now.
Yeah, you can actually peek through there if you want to see the code while you explain.
Yeah, I kind of remember it by heart anyway.
Yeah.
All right, so here we have a, is it the right one?
Any second now.
It's the server.
That's the server.
All right, so there we have a very simple.
Oh, sorry again. Okay. It's better? Everybody can see? Perfect. Thank you.
All right, so we have a very simple Express server set up there, and we are importing the React DOM server rendering library as well. And we have two endpoints set up for that Express server there. One is for the API calls, which serves JSON. It just serves the data that our application uses. And then we have that other endpoint, which serves the HTML. So in other words, when a user first lands on that page, they will most likely end up hitting that endpoint, which serves the HTML. And we are fetching some data from a database or wherever we fetch the data, and we pass that data onto our application component, which is called app in that example. And we pass that component with that data into that React DOM server that renders the static markup, and so it turns that component into HTML markup, and we can serve that as HTML down to the user. And as soon as the browser downloads the HTML and any synchronous dependencies like CSS, which you might have on there if you haven't inlined them, as soon as they have all that, the browser can start rendering the page. Once the browser has downloaded your JavaScript bundle on the client side, it will transform that application into a so-called single-page application where all your navigations or actions you perform on the site will just make calls to that JSON API, which serves the very same content we serve on the HTML render, but this time instead of serving HTML, we're just returning the JSON, and we let the client side handle all the rendering.
Yeah, but basically this is at the core of the universal app in a sense. This is the server side, which basically does the differentiation of how the client and the server kind of is served. But yeah, let's move forward again. Once I find my mouse. Okay, yeah. Yeah, so okay, universal app. Basically what it means is it's code sharing. It's what we basically showed you. The idea is that we'll have the components, which is the bulk of your UI code, right? That's the universal part. That's the big circle that's intentionally made bigger than the client and the server side. So the server-specific stuff, that the file you just saw, it's very small. The same goes with the client side. It's very small, and all the UI code can be ran on both sides in a way, and they create the API for the app. Yeah, we're gonna jump into some more code because Matt said that you guys want to see code.
All right.
That's a funny joke, apparently.
Very funny. Yeah.
That's the
All right. So there we have the entry point for the client-side JavaScript. So again, we are importing a React renderer, but instead of using the DOM server renderer, we are just using the normal React DOM renderer. And how it differentiates with the server rendering is it attaches itself to the DOM on the client side, and instead of just returning markup, it actually mutates DOM elements. So it communicates with the DOM and mutates it accordingly when the data changes or the state changes for the application. And we are also reading the initial state of the application from the window object. And as we are rendering the page first on the server side, we are rendering it with some specific data. And when we want to reinstate the application on client side, we need to do the initial render with the same data as we used on the server side. So there we are kind of just fetching or using that same data that we used to render on server side. We are passing it as the first argument when we reinitiate on the client side. Yeah. So we could now look at another component, which kind of it's sort of like a link component. You could imagine like using something like this for any sort of like a single page application. So what it basically does, it wraps a normal like HTML anchor tag, and
but you can see the A tag here on the bottom.
Yeah. So that's what it renders on the server. It renders a normal anchor tag with some URL and some text. But the difference is that when it mounts on the client side, instead of like, or we are attaching an on-click handler there, and instead of the normal action happening when you click on it on client side, the action handler or the event listener there will actually capture all the clicks that are done on that specific component, and then performing some action as we define it. And for this specific case, we are using that link component to fetch some data, which we then use to update the application. So for example, if you would click on one of those components on your application, it will go and fetch data for that specific page. And instead of like doing a full server render, we're just fetching that JSON and applying it to our application, and we're just updating it down on client side.
Yeah, so basically, as we showed on the server.js, it would actually, at that point, call the API block, and I can show you that here. So when the client event handlers, that's not right, sorry guys. This one. So then this block is called obviously by the browser. Yeah, just to kind of remind you, we don't like to keep this as a one-sided. So if you have any questions now while we talk, please do ask, especially if it's something you don't understand, if we've said something wrong that sounds funny or funky or weird. Yeah.
Can you explain a little bit about the arrow function?
Pardon? Yeah. Yeah.
notation into JavaScript. It just makes like writing components a lot easier when you can write code that is similar to HTML. It's not quite like HTML, but very similar.
Yeah.
And we do use a compiler. We use Babel to transform the code into actually valid ES5 code, so it runs on most modern browsers.
Yeah, so just to make clear, we are using ES6 and JSX because JSX is something that is very often recommended to use with React. Yeah, any other mid questions? Yeah?
Any way to validate the HTML?
Well,
right, so React itself doesn't allow you to make invalid HTML. Like some cases where you try and like make malformed tables, you might run into trouble, but you can't make like syntactically incorrect like HTML with React.
Yeah. If you put a wrong kind of bracket or whatnot, it'll.
Yeah. It won't tell in that case, but it will tell you that. Yeah. And it does allow you to, for example, nest anchor tags into anchor tags, and that obviously doesn't work very well. But it doesn't let you, for example, open a tag and not close it. Yeah.
Cool. Should we move forward or? We found the mouse. Yeah, so data handling. I mean, again, this is not strictly React specific in that sense, but in general, we find that it is kind of React specific, but we find that kind of data handling in web apps tends to be kind of tricky. So obviously, React does not itself deal with data handling. It is focused on rendering, but there are several different ways where commonly in React apps or universal apps, the data architecture, if you will, is handled. And one of them is Flux, which is quite commonly used. But there's kind of new patterns and tools that come up, which some people are moving, and I think we're also moving, which is GraphQL and Relay. We're going to talk about those a bit as well.
Yeah, so a quick show of hands, how many of you have heard of GraphQL before? All right, how many of you have heard about Relay? All right. So GraphQL is basically a query language which allows you to query data from a schema that you have defined, and that schema is strictly typed, and it allows you to easily define the data dependencies for example, a React application. So you can define component-specific data requirements within the components, and then for the whole application, you can compose all those data requirements and just perform a single request to get all the data needed for some specific view. And if that view changes and some other data needs to be fetched, one way to handle it is to just fetch the data that you are missing. So you already have some of the data, but you're still missing some fields. So you might want to just fetch those fields, and that's where Relay comes in. Relay is a library just a couple of weeks, released a couple of weeks ago by Facebook, and it kind of takes care of like fetching and storing the data on a client-side application. So when you define like your data requirements with GraphQL for specific components, Relay helps you fetch and provide that data to all the components within your application. So it keeps data in memory in store, and if it's missing some data, it goes and fetches it from a GraphQL server and then propagates the data onto all the components that are needing it.
Yeah, so if that wasn't clear enough, we'll just show a bit of code, so, you know. Yay. And it's the final code block. Yay.
Scroll down.
Is that all right?
Just go right, so here we have the same component example we used very early on. So it's a hero component, and it has some specific data it uses in the render function. So it's dependent on like a title, a subtitle, and some buttons. And if we define all the data needs for that specific components right there, it's very easy to argue when you make some changes to the component that does it still need those same data, or does it, could you, for example, remove one of the properties, like does it still need a subtitle or a title, or is it still using the button? So if you make any changes to the behavior or the way the component is rendered, it's a lot easier to argue what kind of data it needs. So it just makes it a lot easier to keep the data dependencies where you are actually like defining the component.
Yeah.
It's a ES6 liter string. So this again is going through a compiler. It transforms it into a GraphQL like a relay request. So it does go through a compiler, and basically you would have your at some top level of your application you would have like a root relay container which kind of gathers all the child like component data requirements, and it would then compose out of all those like subcomponents a single like GraphQL request, and then pass it onwards down to all the children. Yes, yes.
Pretty much.
So basically, you have somewhere in your GraphQL server defined a hero like structure. So, say again? Yes. So fragment is like you can define like fragments for a like GraphQL server, like which you can reuse. So, for example, if you have multiple components that want to use some specific fields from your schema, you can define fragments that are reusable, like in multiple places. So, for example, we are here defining a fragment on the hero, but we are then combining that fragment with some other fragments, which are then combined into a single GraphQL request. Yeah.
All right. So yeah, so trade-offs. This is kind of a lot of people. We've talked about with a lot of people who have done React and universal stuff, and so obviously for kind of to be not biased in a way, we wanted to bring out what those people might have said. So, you know, mutating the DOM outside of React can be fairly tricky. If you're using React, so you shouldn't probably then try to modify it with jQuery or something. But yeah, so that's if you want to do that, that's probably not.
It's possible, but yeah, it's not something I would recommend. So.
Yeah. Obviously, it is another library, so take that as it is. Some people might not like JSX, so for those of you who don't know that, the JSX is kind of the language in a way that you describe the components. So basically the HTML stuff. And some people might find that it trashes the HTML. So if you inspect the DOM, you'll find some React stuff there, and some people might not like it. Or that if some people don't like if you do inline styles. Obviously, these are not mandatory, but that's the way we're doing it currently. Yeah, I think we're running out of slides. Any questions and more good questions, and we'll try to answer them as well as we can.
All right, so we are passing all the data that we use to do the server render, we're passing it as a JSON, like embedded into the application. So we're defining it in like a property on the window object as a script tag.
Oh, you're just assigning
We could actually look at the app.js, which is not open at the moment.
I can open it if I find it from. Is this on app.js? Super.
Right. So. Yeah. So we are just escaping some bad characters out of the JSON and then outputting it somewhere down there. I can't actually see where, but it's somewhere down there. We are like applying it into the window object, and then when we initiate the client, we are then reading it from there, and then that's how we are passing like the initial state onto the client side. Yeah. You should really not use it.
Do as we say, not as we do. Yeah.
Last night there was a presentation from an engineer at Meteor at Angular, and he showed using Meteor as the data, in three-way data binding.
Mm-hmm.
And it's really kind of awesome because out of the box, you have the socket, things are refreshing, and you have to do a lot of stuff. Have a look at that. And it works with React, works with Angular, works with Aurelia for that. Did you ever look at it?
Oh, I haven't.
No.
No, unfortunately, no.
So since you guys are loading JSON, that means that like any content on the screen is going to be populated via JavaScript. Are you guys finding that, like for SEO purposes, that crawlers have caught up and like you're not just dumping straight HTML and then binding it for the HTML, right? So are you finding that there are any things to concern yourself with for SEO purposes?
Did you?
I honestly couldn't catch all that, so can you?
So the way that SEO worked in the past,
Yeah.
like crawlers are starting to catch up and they support JavaScript. And
Yeah.
Yeah.
Right?
Yeah.
It used to be that we basically would say JavaScript and just print out a bunch of HTML if you wanted it.
Yeah.
Yeah.
So what you guys are doing is printing out JSON.
Yeah.
No.
So your app is still loading it up.
Well,
we're
first on the.
Yeah. So we are printing HTML.
Yeah.
We're just
On the first load.
Yeah. And with the HTML, we are also at the bottom passing the data as JSON. So we have the data in the HTML and we have the data in the JSON.
Yeah.
So it prints out the rendered page, and then the data that could have printed that out
Yeah.
and sort of like overrides itself.
Yeah.
Yeah.
So it actually has very good SEO like usability.
So you don't have to worry about SEO and linkabilities.
Yeah. So basically, if you build your universal application right, you can disable your JavaScript and it should be still like
Clickable.
clickable. Obviously, everything won't work like as it should, but like basically like page navigation and that kind of stuff should work as is.
Yeah.
Is that the template, the tag that's what's included?
I'm sorry.
The 928, that's where you're printing the initial extension.
That's a component here. Yeah. So we have like multiple templates and we're selecting the template based on the data. So we are fetching the data and the data defines which template we are using on a specific page. And we have, if you scroll up, there's actually a function that fetches.
I can scroll up.
Yeah. So there's a get template function which basically just gets the correct template based on the template property. And well, I mean, there are so many different ways you can do it. That's one way we've done it previously, where we don't actually know based on the URL what kind of template we should be using on a page. Obviously, if you know already based on the URL what kind of template the page uses, then it's a lot easier to define it right there. But in cases where you don't know it, so the data itself defines what kind of template it uses. That's where we've done it before.
Yeah.
What kind of build systems or like setup are you running in order to run this code both on like the server and the client? Are you using like Webpack or?
We use both Browserify and Webpack, yeah.
Okay.
So personally, I do prefer Webpack over Browserify simply because it does allow you to build other stuff than just like JS.
And it's easy to export this for Node, and also do you have to have like separate configuration
do need to like transform. We do need to like transfer the code for Node because we are using JSX and Node doesn't understand. Even if you're like, if you use like Node 4.0, you might be able to use all the ES6 stuff you're using, but since
Not JSX.
yeah, it wants to support JSX, so we do need to like use Babel or something to like transform the code into valid JavaScript. So the way we do it, we register we register Babel like when we initiate the application, so it transforms all the modules that are imported after that.
So, like in the browser, you need to render. I mean, you just call React render.
Yeah.
Yeah.
On Node, you need to render static HTML.
Yeah.
Yeah.
So that's the difference. Like you have to render differently on the server than on the client.
Well,
We are rendering the very same thing. We are just
yeah. We just
one render it. Yeah.
Yeah, exactly. And that's that was the distinction
exactly,
in one.
Yeah. So one of them provides like static markup, and one of them like attaches it to the DOM and starts mutating it.
Yeah. Yeah.
Yeah, a real world example, like if you don't have every URL rendered by, like say if you have a homepage that's static,
Mm-hmm.
and then you have an app that's something else, like you have like I know this is like very nice that everything is rendered the same app. You might have just you have one bundle that you're shipping and everything, like routing and everything
Yeah.
is happening perfectly. But do you guys ever have more complicated stuff where you end up like splitting up different URLs or different apps where like you don't want to have so you have an admin interface that's running all the same
Yeah.
URL where it's like different
Yeah.
bundles, different sub apps.
Yeah. So I mean, if you run into issues where you don't want to serve like all your JavaScript like as a single bundle, it is relatively easy to set up like a Webpack tool which like splits like your application based on the entry and like where the client like arrives to the site. So for example, if they come to an admin page, you serve the admin bundle, or if they come on the home page, you serve the homepage bundle. And how you set it up is you like define different entry points for your Webpack configuration.
Just my app has like just tiny little bundles, and I'm curious over like the benefit of having small bundles in the apps.
I'm definitely in favor of small bundles. Anything that you can minimize your like first initial JavaScript is always good. But there's always some like balance you have to go when you how much do you bundle like together and how much do you like split up, because there is the cost of like requesting multiple like files unless you're like using HTTP2 or something. But there's always the cost of doing multiple round trips. So as much as you can keep in a single bundle, at least at the moment, is probably for good. That will probably change like in a year or two, where it doesn't really matter how many files you have when you just can stream it all like from the server.
Yeah.
Have you guys compared the performance difference between rendering like the static markup in Node using React versus like rendering a template like Jade or Swig?
I haven't.
I haven't measured the
Yeah,
performance. I mean, most of the time you will probably have some.
Yeah, just speak on.
Sorry.
Yeah.
Yeah. So we haven't done like any performance benchmarks, and I'm pretty sure like something like Jade would probably be faster. But the nice thing about React is that you can actually then easily transform the application into a single page application as well. So it works very well on the server. It works very well on the client. And there's very minimal code that you need to write for specifically for the server and specifically for the client. So it just works. Yeah. And like regarding performance, I mean, at least in our experience, we usually have some cache in front of the site anyway. So
if it's static stuff, it's cached anyway. Yeah. And like the last project we did was kind of pretty high performance, and we saw really good results with really high loads as well. So, and it's, yeah. But we just don't have any statistics or comparison.
I haven't mentioned it either, but I know so where I work we do universal JavaScript. And,
Yeah.
I think we suffer on the initial page
Mm-hmm.
render.
Yeah.
But then you avoid subsequent renders because from then on it's just
Yeah.
done. But I do think, like I haven't instrumented myself, so I'm curious if other people really have. But
Yeah. I mean, it would be interesting to actually measure that in a way.
But yeah, I mean, you can just stick to cache.
Yeah, and we every time we do something, we cache the hell out of it anyway. So. Yeah.
Yeah,
Yeah.
definitely. So I mean, you can easily define like some parts to only like work client side or some parts to only work server side. So it's not that difficult like make that kind of logic in your application. Yeah.
Can you speak up a bit more? So I can't hear you.
Yeah. Yeah.
So our
Yeah.
our designer is or the last project we worked with, our designer was, he did some CSS and HTML, but
And actually, he
did.
I mean, we mostly like did the components, like small level components. But once we had all the small level components, the designer himself was able to compose from those components, like all the templates and like do all the designs. So we just made the building blocks, and he was able to himself do most of the stuff himself. And obviously, he's familiar with some JavaScript and CSS. So.
So most of our designers, they are, well, let's say some of them know actual coding and some of them do not, but I don't see a problem actually, because since the components are quite obvious in a way, and when you have JSX, they kind of have to deal with that part in a way. So, I mean, you might need to show them around a bit, but we haven't had that problem yet.
I think it's actually been easier to work with React and designers.
Yeah.
Like on projects where you haven't used React.
Yeah.
Kind of related to that, just you guys use CSS in the actual file injection.
Well, inline style. No, well, the last project we used less, right? But it is possible, and kind of it can be a good way to actually inline the styles within the component.
Yeah, I was just curious if you guys used that on a big project.
Well, the last big project we did.
We didn't.
We
Yeah.
did use less.
Yeah. And a middle ground to that is as well to use like CSS modules or something where you like import the CSS and and then with Webpack either inline it or then build like separate bundles for the CSS. But there are a lot of different ways you can handle it, and there's tons of like open source projects for React regarding like CSS and styles and all that. So one I would recommend Radium, and one is a React style. But there's like plenty more, and all of them are. I don't think there's still a single like perfect solution. Like for example, Radium, as far as I remember, doesn't very well handle like server rendering and media queries. So if you want to make a responsive site which is universal, there is still some work to be done there. Whereas for example, React style, as far as I recall, does support that case, but it doesn't support something else that Radium does. So all of them have like some parts which is still kind of like almost there, but not quite. Thank you.
Okay. All right, so thanks for listening. Thanks for the great questions. Thanks for Shutterstock for hosting. We are also hiring. We don't want to step on Matt's toes, but yeah. So we're also hiring, so not just Noders, but all kinds of developers and even designers and stuff. So check us out at www.reaktor.com. That's our Twitter. I don't know if somebody cares, but Nicholas tweets a lot. All right, so yeah. Oh yeah, we brought some swag. So if you're interested in really, really awesome visors, not my idea, and some kind of sun hats of some sorts, you know, it's on the table. Please come and pick. And if you want to chat with us, just come and talk and yeah. Yeah. Oh yeah, you can be the model. Oh, come on.